All right, so let's get started. Previously, during our lectures, I mentioned some about the asynchronous object that is used in Angular, and this object is called the observable. But actually, observable isn't exclusive feature of the Angular, but the most of the Angular APIs use the Rx.JS as the basis for any of the dependency services, like the HTTP client instead of promises, use the observables, and any other subscriptions are used to maintain, to handle the asynchronous operations in Angular. So I guess this is the necessary part during the Angular course. And I have to warn you that today's topic perhaps could be really tough to understand. So let's stay focused and start reviewing the Rx.js features and what actually the observable is. Let's first have a look what the Rx.js is. So this is the library which implements the reactive programming paradigm. So actually, the reactive programming is all about the data streams and reacting to the data changes. And if you're curious about what the changes are, that could be any. Let's say you subscribed to weather changes. So let's imagine that your widget on your mobile phone is connected to the weather forecast servers and fetching the data, constantly fetching the data about the forecast and the current status, or what the temperature outside, whether it's rainy, snowy, freezing, and so on. And your widget is reacting to the forecast changes. So this is the most common case. But most important to understand that reactive programming, Rx.js in particular, this all is about the data streams. The main focus will be on the observable. So we'll take the closer look on it in a second. And the help of observables, we can easily not only to maintain the asynchronous operation, but also transform the incoming data in any forms as we want. So in case if you are working with some other libraries, let's say you're working with React or any other library, or your project uses the pure JavaScript, so you can easily integrate the Rx.js into your project by just installing the library which is called Rx.js. What's actually the observable is? If we take the closely look at the word and which part it consists, we'll see that this word consists of the part able. What does it mean? Well, actually, this is the object that could be observed. If we take the example with iterable, like the arrays or any other object that are iterable, it means that we are able to iterate over that object. And with observable, the same picture like here. So this is the object that could be observed. So what's we observing? We're observing the changes, observing the data, the latest data that is upcoming from the observable. Before we take a deeper close on how can we start working with the observable, I would like to create the simplified version of our observable. I mentioned iterable just because this is the close example that could be referred to it when we are speaking about the observable. So, well, what the iterable object is? So it consists of the collection of data. So we can create some sort of array. We can iterate over it. Let's say for each, we can iterate over each element and do something. We can transform this array in by any means, by filtering items or by changing every item in the array, and so on. And we are going to, as we want to learn the observable, let's create the simple function and call it observe. That will take any upcoming element and perform some operations. Let's do the following. We're going to iterate over each element. And if we call this function with some kind of callback and just log the upcoming source data, let's try to run it. We'll see that we are iterating over each element, and we are able to extract all of them and perform some kind of operations. Nevertheless, we're able to perform some other operations like error handling and something that will be triggered when we complete observing the source. So let's say we're passing the next callback, which is error. That could be like this one. Well, that could be something like this. Oh, well, this is the triggers. How can we start working with the collection of data that is being observed? So let's try to run once again, and we will see that the collection of data is iterated. We can listen to any data from the source and react to the completed state. Well, and in case of some errors, let's just emulate this behavior. If data greater than 2, the error will be occurred. Otherwise, we're going to continue our observation under the collection of data. So, and as of the observables, we have the same flow. We are subscribing to the collection of data, and the main difference between our example and the real-life observer is that the real-life observer can contain the endless collection of data. Whether the array has the concrete number of elements, but still we are able to observe the data, the upcoming data. Okay, but as I mentioned, there is some functionality in Rx.JS that enable us to transform any kind of data that is going to be pushed to all of the subscribers that are listening to the data. So for this purpose, we need some more complex structure. Let's say we want to have the class observable. So it accepts some data source. We're going to assign this data to the object. And in the observable, there is a method subscribe. That will actually return the current source that is obtained. So let's go ahead and try to create the subject. Again, this will be the array, and we're going to subscribe. But as we mentioned, the subscribe can accept 3 callbacks. Let's try to do this. Okay, what's going on? Wait function return value is used. Well, I guess that's not a problem. Well, at least we need to iterate over the data source. And do all the logic that is performed observable. Let's try to run it. Wait function return value. So how can we disable these wordings? Well, let's do the following. And okay, so the same syntax as in the real life example, and we need to perform some transformation operators. So let's say since we are working, but actually we can not only pass the array, we can also pass the string that is also the iterable, and we can listen to any other piece of data that could be extracted from the iterable object. Well, let's do like this. Let's see what's going on. Yeah, that looks pretty awesome. We're listening to every letter of our string that is passed as the data source. Let's try to implement some other filtering and any other operator that could be used. First of all, in the real life world, there is the method that is called pipe, and it accepts the operators. Let's see. So if we perform this logic for each time, our data source will be transformed. So let's have a bunch of operators. Let's say you want to have the filter functionality. The filter that will accept some sort of callback. Reach. Well, let's put it just simply and create some operators in the following way. Filter that will do the following. Let's see what we'll have. The source. And also we need to return this. Well, what's going on? Why it's not the function? The source. Okay. Let's do like the following. With the strings. Yeah, the filtering works. So but in this example, we see that we not only observe each piece of data that is passed as the whole collection, so we can observe each element, and before we get the final result, we are able to do some preliminary transformations until the data reaches the endpoint, which is the subscriber. Okay, this is the preliminary demo of how the observable will look like. But what happens in the real life world? So let's see how the observables look like. As I mentioned before, there are three methods on the subscription. There are next, error, and complete. So like in my example, we also have three callbacks. This is the next callback, which reacts to the next incoming data. The second callback is for error handling, and the third one is for the completion. The complete is called when the observable completes how would say when we complete observing some data collection. If the data collection is finite, like arrays or strings, the complete will be triggered when we are finished iterating all the elements. However, if we are having the endless collection, let's say you are working with the event handling, like in pure JS, you're registering the event listener and assigning some sort of callback. Well, this is the possible example where we can say that the DOM events are the endless data collection that could be passed over and over again. So in this case, if we want the observable to be completed, we need manually to, well, to do like the following, to explicitly complete by invoking some kind of methods. So 3 methods, next, error, and complete, as I mentioned. Let's see. So this is the way we can create the observable using the Rx.JS library. Let's see what's going on here. First, we are invoking the method create, or creating the instance of the object observable. It doesn't matter. What matters is that during the creation of observable, we are passing some sort of the callback, like we deal with the promise. Well, we'll look at the differences between the observable and promises in the next couple of minutes. Let's just see what's going on here. As we can see, the callback, which is passed to the observable create, will be invoked instantly when we create the observable. So what do we have? The method next. Actually, the observer is the object which is called the producer. The producer will push each element, each data to the subscribers, and to notify subscribers about the changes, we're calling the method next. And each time we're calling the method next, the subscriber will be triggered and the value will be printed to the console. All right. And it will occur, in our case, each 500 milliseconds. So each interval will trigger the new change, the new data that is passed to the subscriber. And we will see the new counter value. Unless we call the method complete, so when the observable is about to be destroyed, or when we complete it, at that moment, the function that is returned from the callback will be invoked. So this function is called at the moment when the observable is destroyed. And to destroy the observable, we are calling the following methods. Let's see how can we create observable in the live example. So this is the same code snippet, and like I mentioned, you can create it by several ways. In some documents, perhaps you will see that we use the observable create. However, the WebStorm notifies me that this is the deprecated symbol. And in the latest examples, we are creating the observable as the object instance. So let's try to run this example. I'll do like the following, source C, observable creation. Well, as we can see, each 500 milliseconds, we notice that the subscriber works and it prints to the console the new value of the data that is passed by invoking the method next. And this is the endless data collection. If you want to compare the observables with the promise, so this case is not possible if we want to do this the same with the observables. Okay, so let's just remind what the promise is. If we refer to the syntax of the promise, it actually looks pretty similar. We pass the callback with two params, resolve and reject. And if we try to do the same logic with the promise, let's see what will happen. Your retry just 0, and we don't notify it about any other changes. Well, that's because when the observable becomes resolved, it can have only one value. So once the promise is resolved, so this is the final state, and we're not able to push any other data to the promise. Well, let's see some other examples. So again, the same counter. So let's change the deprecated symbol to the new one. This is the more advanced example to log every stage of the observable state. And actually, observable also has some states. So first, the observable is created, and the observable is completed. Or observable can be destroyed without completion. Let's try to run this example and see what's going on here. We see observable is created, and it starts pushing the new value to the subscribers. Well, let's see. And each moment the observable is destroyed. That's because we call the timeout, and after 4,500 milliseconds has been passed, we are calling the unsubscribe, which means that the observable will be destroyed. So, and when the observable destroyed, the following function is called. However, we don't see that the third callback has been triggered, which is the complete. That's because we called the just unsubscribe, which means that destroy the subscription and destroy the producer. Okay, let's try to invoke the complete, but the main difference here is that the complete should be triggered under the observer, which is the data producer. Let's see, if the observable completes, only then the third callback will be triggered, and still when observable completes, it's going to be destroyed, and we see that the corresponding message has been appeared in our console. Okay. So let's see what other examples do we have. About the errors. In case we want to trigger and handle some sort of errors, it's also possible. Let's see what's going on here. Again, the same counter. In case of errors, as we can see, the second callback has been triggered, but the third one, which is for completion, has not. Okay, and well, I already showed you the how can we call the complete method under the observer object, and this will look the same as on the second example. All right, so before we move on, I would like to stop here and wait for your questions. Is everything clear for you at this moment, or something you want me to clarify? All right. I propose to make a comparison between observable and the promise. So as we found out, the promise is not able to hold more than one value when the promise is resolved. So it cannot change its state. And that's why if we want to do the same logic, but in terms of observable, that's not quite possible. But there are some other differences. That's where we're going to have a look. All right, the first case, 0 references both to the promise and to the observable. So if you were attentive during the previous lectures, I mentioned that observable won't work unless it has at least one subscriber. We reviewed this case in terms of the HTTP client, and this is the most common gotcha. So if you see that your observable doesn't work, so please be sure that this observable has at least one subscription. And in this case, we see that even we didn't specify the then callback, the promise is still be created, whether the observable is not. All right, we see it. As for the at least one reference or one subscription, both to the promise or the observable, we'll see the result. But important note here is even the promise has been created earlier than the observable, we will see the observable value in the first place, and then the promise result will be printed. Well, that's because the observable has been created, and we already passed the value to it, so it already holds in the observable and waits for the subscriber. But however, as you remember, the promise is the common example of the micro tasks. However, as we see, the observable result comes first. Well, that's because the data, when we subscribed to the observable, is synchronously passed to the subscriber, and we will see the log before we obtain the promised result. Let's see another case. 2 subscriptions. What's going on here? Here's the interesting case. Let's see. We triggered promise then source subscribe. So the promise is anyway has been created. The observable has been created the first time because we subscribed to it. And when we subscribed, we already see the observable result come first. Since promise done leads us to creating the microtask in the microtask queue, we jump right to the next subscriber. So remember that 2 promise dones are pushed to the microtask queue, and so we see another interesting thing. It's when we performed subscription the second time, the observable has been created again. And what do we see? And what conclusion can we make? So each subscriber will cause in creating the new producer. So actually the callback passed to the observable create will be invoked each time we subscribe to this observable. So each new producer will be created by default when we use the method subscribe. And at the same time, the promise is created once. It is possible to have multiple promises done, so we can obtain the promise result in multiple places, but we're not able to push another another value to the promise, since it's possible to have only one and only one state. Let's make a conclusion. So, like I mentioned, the observable does nothing until it has at least one subscriber. Promise creates only once, and it can hold only one value that is already obtained. And observable creates producer for each subscription. So just for you to remind that the producer is everything that goes here, and the object that is passed to the observable creation is the producer, which has the method next and error and complete. All right. Let's see. Okay, so about the comparison between promises and observables, is everything clear for you? Yeah, that sounds cool. That everything is clear. Well, let's go further. Rx.JS is the powerful library that enables us to transform any incoming data and also perform it provides some other ways for observable creation. So let's review them. First, instead of making the huge construction of creating the observable, we can use the function of. That will lead in creation of the observable that has a single value that is going to be passed to the subscriber, and this observable marks as completed since we have the only one value. The from function, which will create the observable from the finite collection of data, iterable data. That could be strings, arrays, and any other array-like objects or any iterable object. And this observable is also be marked as completed since the data collection is finite. So here, the first and the third callback will be triggered. Let's move on. How also can we create the observable? Well, actually, there are lots of ways that can be used to create the observable, like range of numbers, the interval. Instead of using the native set interval while creating the observable, we can obtain the same results via invoking the function from Rx.JS. And this syntax tells us that inside of the pipe methods, we can pass as many Rx.JS operators as we want. And these operators, actually, this is the main feature of observables. These operators can transform any data or to subscribe to another data. These operators can perform any transformations, and these operators brings lots of flexibility into the promises, or sorry, into the observables world. Let's see what else do we have. Throw error. This will create the observable with the error state, and in this case, if we subscribe to this observable, the second callback, which about the error will be called, the empty will emit no value. Well, it could be useful when we are dealing with some error handling, and we don't want the producer to push any other values, and then well, the empty and the never. Well, like I would say it would never push the data. But these are quite rare case. I would say the throw error is like the most common of the list. Well, let's refer to the examples with the same function that we've mentioned in the slides, and we'll see what's happening here. So let's start this file. Not this one. Creation operators. Okay. as we see, um, as for the the function of, like I mentioned, it pushes this single value to the subscriber, and then it marks as completed. From iterates over the iterable collection, and then marks as completed. The range that creates like the increment of the number. So we are defining the start point and the count of the range. And when the range is finished, the observable is also marked as completed. As for the interval, it's still pushes the new data. As for the throw error, as we see, only the second callback has been triggered, but the completed isn't. That's because the observable on error, if the error is occurred, the observable is destroyed without any explicit completion. The empty will not push any data to the subscriber. It's just the empty observable that already completes. As we can see, the empty is completed, and the never is not. Never has started and never be completed. All right. As for the actually there are if we'll refer to the documentation shortly to review all the operators, at least the most popular of them. But I believe I covered the most common of them. Before we move on to the error handling, is everything clear at this stage? So can we go further? Yeah, I believe the creation operators are not so difficult. All right, let's review how can we handle errors and observables. First, there are actually the several ways. One of them is to pass the second callback in the subscribe method to catch all the errors. But there is another option, is to use the catch error operator. Well, actually, what's going on here? So in case if something inside the observable will cause the error, the catch error operator will be triggered, and this operator must return the new source, the new observable. And in this case, when we use the catch error, the error will be logged, and since we returned the new observable, actually the first callback will be called with the string safety result, and this observable will be marked as completed since we passed the observable which is created with the help of the auth function. Let's move on. There is also the possibility to perform some retrial. It could be handy when you want to make the repeated HTTP requests in case of a failure to retry some number of attempts and only then notify the subscriber that something goes wrong. We'll see how it works in a couple of seconds. I have the examples for it. Retry when. What's happening here? Well, let's see. Okay. In the retry when, the retrial will occur when the observable, which is passed here, will, I would say, will emit the new value. So let's assume that we created the observable, something goes wrong. Before we retry to obtain the new value, we'll wait for 1 second. And then the inner observable that is passed to the retry when the value has been emitted, will perform the retrial once again. Let's see, what do we have else? On error resume next. Actually, it accepts another observable, and it will result in the following. If in the source there is some error occurred, this observable will be switched to another one, and during our subscription, we will see the string nice solution. So the first callback will be triggered and the completion as well. That's because of the error we switched to the plan B. And it will be invoked because of the error within the first initial observable. Let's try to run all of these examples and see what's happening. Okay. As for the throw error, sorry, for the catch error, we see that the observable next has been triggered with the string safety result. As for the retrial, we started this observable. We see that it caused the error, and it attempts over and over again. But this number of counts that is passed as the argument of the function retry. And so when the retrials limit has been reached, the error callback has been invoked. As for the retry when, let's see what's going on here. Retry when, we see, so that's the started. It tries to make some sort of call. We see that the error has been occurred. We create the new observable, and when it emits the value in 1 second, let's see, we make another call. So actually, we create the new observable, the new producer, and since our flag changed from true to false, we'll see the success result. And as for the on error resume next, we obtained the nice solution since we switched to another observable in case of any errors. But the main mechanism of catching the errors, of error handling, actually the most popular are two. One of them is to pass the second callback to react to errors, but the most preferable solution is to use the catch error as the pipeable operator. We'll talk about all, at least the most popular pipeable operators in a couple of seconds. We saw one of them. This is the catch error. So if you encountered some error on the backend or whatever data source, this is the most preferable way that's allow us to handle the errors. This is via the catch error. But still you're free to use the callbacks as well, right? So any questions at this moment? Okay. Well, at this slide, like I mentioned, there are lots of the Rx.JS operators that can be passed to the method pipe, like we performed with the catch error. And at this moment, I would like to refer to the Rx.js documentation. And just for you, let's scroll to see what do we have. There are a bunch of transformation operation, filtering, join, multicasting. There are lots of them actually. So you can refer to each of them at any time. And there is another awesome resource which is called the Rx.js marbles. With the help of this resource, we can see the result of each of that particular operator. For example, if we refer, let's say, to the filter, we'll see that there is the observable that emits these values. But the target observable, so if we subscribe to it, we'll see only 3 of them. These are the numbers that are greater than 10 as we passed it to the filter. So let's review the list of the operators and choose the most popular from them. Let's see. One of the popular and the simple is the map operator. So any operator takes the callback, and as for the map operator, it will transform any incoming data in such a way that the numbers will be multiplied by 10. Actually, you can perform any other transformations. So if we, I would say, if we compare the same approach with the arrays, so you call the map under each element of the array. And in this example, we're covering the map operator under each element of the data source. So I guess that's pretty simple. So if we refer to the example, so here, if we run the sample code, we'll see that when we subscribe to the data source, we'll obtain the client X from the event object when we subscribe to it. Okay, so let's see what else do we have. The map2, which doesn't take any any callbacks, it will, instead of the input data, it will return the letter A each time. Let's see, do we have the plug operator, which actually just accesses the property of the incoming object and returns the value of the property. It's like a syntax sugar. What else? Exhaust or exhaust map. We'll see the rename to exhaust all. Let's see the exhaust map. What do we have here? Well, maybe let's see within the Rx.JS marbles. It's maybe will be simpler to and for you to understand. Where do we have merge map, switch map? And do we have exhaust here? I guess no. Okay. So anyway, you can refer to it. It's actually the rare case, but in case if you need to react to the changes only when the previous value has been pushed, in case if you, it works like a debounce. If you are familiar with debounce, when you put some, I would say, endless value when you just type in something in the search bar and you want the request to be sent only when you stop typing. So the same here, the exhaust map behaves the same. But okay. Okay, they have the map 2, plug, switch map, and the switch map 2. Well, actually, this also the most, I would say, this is the most popular operator, and it just does the following thing. Well, I see that the pictures is quite unclear on this documentation, so let's refer to this one. Okay, so what do we have here? We have two observables, and when we trigger the switch map, and it's actually behaves in the following. It subscribes to the inner observable that is passed as the return value of the callback, and it will subscribe to the value of the inner observable. Well, I see that these examples are not quite clear, so let's try to implement the live example. Let's say we have two data sources. Observable 1, which is well, let's say we want to do something like this. And if we do the following, we subscribe to observable 1. Let's assume that we performed some request to one backend endpoint, and depending on the results of the first request, we want to make another one. So we're doing the switch map. So here, just for you to demonstrate, to demonstrate that the value has been passed here, and we are returning the observable too. Let's try to subscribe to it and see what's happening. Observable 1 start. So we haven't imported the switch map, so let's do it. And this is not the interval, let's time out. Let's do the following, and it will result in 2 seconds. Well, okay. Perhaps I forgot the reference to the timeout in Rx.JS. So let's see, because this is the pipeable operator. Okay. Well, let's do the following. Pipe timeout, let's say 5 seconds. And let's try this again. Oh, not timeout maybe, but delay. I think that delays, they are option. We see that the observable one starts, and we have only one subscription. And this subscription will be triggered only when the inner observable that is passed to the switch map will emit the value. And as we observed right here, so the switch map has the access to the previous value. So let's say we retrieved some result from the previous call and want to make another call to the backend. So I can perform the switch map. Okay. This is about the switch map. And similar to the switch map 2, that doesn't accept any callbacks. It accepts only the inner observable. In case if you don't care about the previous result, you can like call the operator with the suffix to, like map to switch map to, that accepts the value or the inner observable that's going to be used. Well, okay, I guess this is much more clear than the examples in the documentation, I believe. So let's go further and see what other operators do we have. Concat map. Project its source to the observable, which is merged in the input observable. Okay. Let's assume that we are clicking the button each 1 second, and this button will trigger the request to the backend. So if we do the switch map, so how can we demonstrate it? It starts, and we don't see any console logs right here. That's because the inner observable has marked as completed because we pushed another value to the observable one. Let's, for our convenience, do the following. There is an operator which is called finalize. That is triggered when the observable marks as completed. Okay, and let's see. Yeah, and each time the request is canceling, because each second we push in the new value to the pipe, and when we resubscribe via the switch map to the each request will be cancelled. But what if we want still the request to be triggered and we don't want the request to be cancelled? There are two options: concat map to so let's see what's going on. Retrieved some value, but let's do the following: concat map observable to. Yeah, as we can see, we have the delay in about 6 seconds, or about it. But you see that we obtain the result quite slowly. That's because during the concat map, we await while the previous request will be resolved. And let's try the merge map too, or the merge map if we want to make use of the previous value that is pushed to the observable one. And let's see what's going on here. Yeah, we obtained the request results much faster, and the request has not been cancelled, but marked as the observable is marked as completed. I'm going to refer to the Rx.JS marbles once again and show you what's actually going on. Okay, so we reviewed two operators, the concat map and the merge map. Okay. As we can see, we'll obtain the final result only when the element from the inner observable has been emitted. And if we refer to the merge map and do the following, let's try something like this, and the same with concat map. A1, A2, A3. So when the second observable completes, only when we start working with the second value of the first observable. This is the concat map, and during the merge map, we started working with the second value of the first observable. right away. But I want to show you practically the difference between concat and merge map in the terms of the dev tools. If we try to perform the request, if I will find find the real life example. As we can see right here, if we use the concat map, it will behave in the following. So each new request will wait until the previous one will be finished. And if I believe we scroll down to the merge map, as we can see, each time we produce the new value, we will send the requests in parallel. And if we perform the switch map, well, I believe there will be some example right here. So each upcoming request will be cancelled until the first request will be finished. And also there is the reference to the exhaust strategy. Like I say, it behaves as the debounce, and each time we perform some operation and pushing the value to the observable, it will result in nothing because the previous request hasn't been completed yet. All right, so I will push post every link to the Discord just for your reference to take a look at the materials. All right, this is for the transformation. There are a bunch of filtering operators. Let's review some of them, some of the most popular. So we took a look at the filter, briefly took at the take operator that actually marks the observable as completed if we've taken the particular number of values. The take until or any other operator from the take family will mark the observable as completed under some condition. Skip while, skip until, so it behaves like a filter, but we can pass the number of elements that we want to skip, or even we can pass the observable or any condition to the skip while function. Yeah, and see, so there are lots of operators as you see. Okay, let's see, do we have else? So as this is for the transformation and filtering operators, and also there is the possibility to combine the observables, combine some of them. If you refer to the promise, promise has such ability to combine multiple promises, and we can achieve the same with the observables. So before we move on to the next category of operators, do you need me to review something that is not quite clear for you? Maybe you have questions, but still, you can refer to each of the operators or examples in the documentation. For now, I want you just to know that the Rx.JS and the observables in particular enables you to transform any incoming data in any ways as you want. Okay, this is the goal of our today's lecture, just to bring the understanding that there are lots of operators, and some of them are used, I would say, used frequently, and it brings lots of flexibility in the asynchronous development. So waiting a couple of seconds for your question, and then we'll move forward. We can use Rx.JS in React too, that's right. Yeah, absolutely. So there is no any restrictions of using Rx.JS in this or that particular library. So uh, if you notice that I don't have any any symptoms of Angular in my examples, I use just pure JavaScript or TypeScript in my example. So I can use the Rix.js in any forms. And in React, you can also install the Rix.js and use it to bring the flexibility in your application. So actually, this is the powerful tool for managing the data streams. So I guess you can use it, and I would say you should use the Rix.js. It's to enable lots of feature. Okay. All right. So I know there are lots of information for today. Uh, so let's move further. There are a bunch of the combination operators. So in promise, we also have some of them, the promise all or raise. The Rx.js also have the possibility to combine the several number of streams into one. So let's refer to the examples. First, the concat operator. So it will create the single observable, in our case, of 2 ones. And the observable will be completed only if both of them will be marked as completed. And as you noticed, that until the first observable will be marked as completed, only at this moment, the values from the second one will be pushed to the result observable, and it will result in the following. So even if we like, I would how to say, even if we define the larger delay in the first observable, it doesn't make any sense to the second one, since during the concat, it's wait for the completion and not the timeout. So let's go on. Well, the merge operator, unless will not wait for the completion of the observable. It instead will push to the resulting subscriber any of the values. And as you see right here, the second observable pushed the update right after the first emits the number 16, and the subscriber will receive the value from the second, even if the first observable is not completed. So if you need to combine the data from two sources or any other amount of sources, so you can use the merge operator, the merge function, right? So let's go further. So this is the kind of interesting operator. In comparison with merge, it waits for all of the sources to emit at least one value. And it will combine all the received value into the array. So as we can see, the subscriber will receive the value, the array only and only if two of the sources will emit the value. So here, in this example, we will not see the 2a, we'll see only 2b. That's because after emission of the value, it will still wait for new values from each sources. So the zip operator will work as the following. So here the D is ignored because the first source did not emit the value before the C. So you can refer to the diagram to see how the zip operator works. Okay, so let's go on. The combine latest will not wait for each value from each source, and instead it will result in array, and when one of the sources will emit the value, it will result in pushing the array with some of the changed value to the subscriber. So it won't wait for each value from each source, and instead it will result in array, and the array will be changed each time when something has been changed in any of the sources that are passed to the combine latest. All right, the next one, the fork join. Fork join will wait until all of the observables that are passed to the fork join operator will wait once all of the observables will be completed, and only then it will emit the value to the target subscriber. This operator is useful when we are dealing with the network requests. Let's say if we refer to the HTTP client, so each observable that is created from the HTTP request is marked as completed when the request has been finished. So this will be useful when you pass multiple HTTP client calls right here and awaiting for all of them. All right, what else do we have? From event. That's pretty simple. Instead of referring to the document or any other element and invoking add event listener, we can simply use the from event function to pass the element and the name of the event that is going to be handled. So this is the simple way of creating the event handler that will be in the form of the observable, and we can work with it as we want. So I guess nothing difficult right here. What else? Starts with is the operator that will immediately pass the starting value to the subscriber, even if we are still waiting for some kind of response. Let's say we want to retrieve the array and we don't want to handle cases whether the reference to the array is undefined, so maybe we want to start our source with the empty array, and then we'll wait for other values to be emitted. So if you want to define the default value for the source, then use start with. All right. So let's refer again to the doc and see what else do we have. The merge race, and like the race is pretty simple. It behaves like the promise race, I guess. Nothing is difficult here. But in case to remember that if one of the sources will emit the value fast, then we'll subscribe only to this one. Well, do we have so combine latest merge for join zip the merge which behaves as the merge map, so we reviewed already. Transmission operators will already transformation we reviewed. Filtering, join, utility. Well, I guess as for the minimum for your further development, I guess we reviewed everything. But if you are curious about what else the Rx.JS can propose you to organize the interaction with observables, so you can refer to both of the sources, the list of the operators right here, and the Rx.JS marbles to see how the observable will behave under this or that condition if we use some sort of the operator. All right, any questions so far about the operators or Rx.JS itself? Well, in this case, let's go further. Actually, the last topic for today. So let's be patient and to stay focused to this one. And the most common question on the interview, but don't be scared at this moment, because if you will start if you try if you try to pass the interview at this moment like junior specialist, perhaps this question won't be asked to you. But for your understanding, when I was passing the technical interviews, this question actually is the frequently asked if we are speaking about the Rx.JS. I will not dig so deep into the details, just to you to bring some basics. And in case you feel you will be curious about some details, so I will leave the link to the topic. So the observable can be hot and cold. So what does it mean? So observables are cold by default. It means that every time we subscribe to the observable, it will create the new producer over and over again on each subscription. The hot observable behaves differently, so it won't create the new producer on each subscription. Instead, it will have only one producer for each subscriber. So about the details. In case of the error or the observable completion, the hot observable will have to create the new producer, since because the previous one has been already completed. Okay, so let's refer to the diagram right here. As I mentioned, when we have subscribed to some cold observable, actually we have one copy of the producer, and each time we subscribe to the cold observable, each new producer will be created as well. As for the hot one, we have well, some layer if we to use it to connect with the single observable producer. However, what the subject is, we'll review right now. Actually, this object is the special object in the Rx.JS that combines two objects, the observable and the observer. Just to remind you, that observable has several methods, subscribe and pipe, and the observer, like we noticed during the observable creation topic, has the following methods: next, error, or complete. So the subject has all of the methods that are listed right here. It means that the subject is the combination of the observable and the observer, or in other words, the combination of the producer and the consumer. So the basic usage of the subject. So subject is, I would say, is also the common case when we are dealing with the Rx.JS. And let's assume that if you want to create some source of data by hand, manually in the Angular app, and let's say you want to store the current user state, and you want some other components to be notified about the state change, so the subject is your option. So we simply create the instance of the subject and invoking the listed methods. By calling the next method, we are going to pass the new value to the subject, and we can complete the subject as well as any other observable. But here is the catch. Let's see the console output right here. So we subscribed. The first subscription will work since we subscribed to the subject in advance and called the next method. It will result in the following. So the first next has been triggered with the value yes I can, and the completion callback has been triggered. However, due to the second subscription to be used later than this subject has been completed, we only have triggered the third callback in the second subscription. It means that if we subscribe to the subject after we push some value, the second subscription will not retrieve the latest value from the subject. To handle this case, and if we want to have the ability to retrieve the latest value from the subject, we need to use another object, which is called the well, actually not this one, but we'll refer to this in the next slide. But first, let's review what the behavior subject is. Well, actually, this is the same subject, but the only difference here is that we are able to define the default value for the subject, for the behavior subject. And when we perform the subscription, first we retrieve the default value, then we retrieve some other value via triggering the next, but still the second subscription is not able to see the latest value of the behavior subject. So if you're curious about how can we achieve it, so your option is the replace subject. Well, the replace subject actually solves the problem when you're not able to take the latest value from the subject. So replace subject gives you that option. So as you can see from the example output, we're able to use the latest value from the subject. Well, and the last subject, the last type of subject is the async subject. Well, actually, this subject behaves like the following. The async subject will emit the value to the subscriber only when the subject marked as completed. Only then you will retrieve some data. So as we can see, we don't see the number 1 in the console just because the async subject still waits for the completion. And only when the async subject is completed, we'll see the result in all of the subscribers. I guess that's clean at this moment. And before we wrap up our today's lecture, just to show you another topic, it will be for this for the self-learning. It's about the multicasting and halt and called observables. So if we review all of these objects, actually all of the subjects are the examples of the hot observables because we have one single producer for all of the subscribers. So let's review some of the materials and see a subject subscribe, making hot, publish. Well, okay, let's find some of the links for you to review. I'm just trying to find something about the multicasting because I guess it will take much time for us to review it. Well, I will leave at least this link, and if I find some other material about making the hot observable from the cold one, it's about the multicasting, so I will share with you as well. However, as for today, I guess we've covered everything to start working with Rx.JS. And the final question for you, whether everything covered today is clear, or maybe you need some other live examples to be sure that you have the particular understanding on how this or that functionality works. So don't hesitate to ask me everything. So I'll wait for your questions. Well, I hope that everything that was reviewed today is clear for now. But still, if something is still unclear, so please reach me. So I'm ready to answer all of your questions regarding this topic or any previous topics, or even if you're curious about the upcoming ones. So I'm ready to chat with you. All right, seems no questions from you. So in this case, see you next time.